Imagine waking up tomorrow to discover that one of the most famous events in the history of science never actually happened. Every textbook, every documentary, every image of the early universe expanding from an unimaginably dense point would suddenly become incomplete. Not necessarily wrong, but far less certain than you were led to believe. Because despite what many people assume, modern cosmology does not actually prove that the Big Bang was the absolute beginning of everything. It proves something far more subtle and perhaps far more disturbing. For decades, the phrase, the Big Bang, has become almost synonymous with creation itself. We imagine a cosmic explosion emerging from absolute nothingness, giving birth to space, time, matter, and every galaxy that would ever exist. It is one of the most recognizable scientific ideas on Earth. Yet the deeper physicists have investigated this event, the stranger it has become. The evidence supporting the Big Bang is extraordinarily strong, but the evidence that it was the beginning of reality is surprisingly weak. That distinction changes everything. Because if the Big Bang was not the beginning, then the greatest chapter in the history of the universe may actually be missing its first pages. And once you begin asking what came before, you quickly discover that science enters one of its most mysterious frontiers, a place where observation, mathematics, and philosophy begin to overlap. Look around you for a moment. Every object you can touch, every atom inside your body, every distant star visible in the night sky, traces its history back to an incredibly hot and dense early state of the universe. This is what cosmologists mean when they describe the Big Bang. They are describing a period when the observable universe was compressed into conditions so extreme that our current laws of physics become increasingly difficult to apply. Notice something important. That description never actually says reality began there. It only tells us that if we rewind cosmic history using the equations we currently possess, everything converges toward an unimaginably dense and energetic state. Beyond that point, the equations themselves begin to fail. This is one of the most misunderstood ideas in science. The Big Bang is not a photograph of creation. It is the edge of a map. Beyond that edge, our mathematical compass stops working. And when the map ends, two possibilities emerge. Either reality truly began there, or our understanding simply does. Throughout history, humanity has repeatedly mistaken the limits of knowledge for the limits of reality. Ancient civilizations believed the ocean ended where the horizon disappeared. Later generations imagined our galaxy contained the entire universe. Every time we reached what seemed like the ultimate boundary, we eventually discovered another landscape waiting beyond it. Could the Big Bang represent another horizon rather than an absolute beginning? That question has quietly become one of the most profound investigations in modern cosmology. To understand why, you first need to imagine something almost impossible. Forget galaxies, forget stars, forget atoms. Continue traveling backward through time until even light itself has not yet begun its long journey across space. Temperatures rise beyond anything nature produces today. Matter dissolves into fundamental particles. Those particles merge into an exotic plasma unlike anything your senses could ever experience. Continue further. The universe shrinks. Distances lose meaning. Energy becomes so concentrated that gravity itself begins behaving in ways no experiment has ever directly observed. Finally, you reach what appears to be a singularity, a point where density becomes infinite and the equations produce impossible answers. Infinity is usually a warning sign in physics. Whenever an equation predicts infinite temperature, infinite density, or infinite curvature, physicists rarely celebrate. Instead, they become suspicious. Infinite values often signal that the mathematical model has reached the limit of its usefulness rather than revealing the true nature of reality. Imagine using a map of Earth while standing on the moon. Eventually, the map stops helping. Not because the moon does not exist, but because the map was never designed to describe it. Many physicists suspect the same thing happens near the Big Bang. General relativity successfully describes enormous structures like galaxies and black holes, while quantum mechanics governs the microscopic world of particles. But near the earliest moments of cosmic history, both theories demand to be used simultaneously, and they refuse to cooperate. This conflict has become one of the greatest unsolved problems in science. It suggests that the universe is asking questions using a language we have not yet learned to speak. If that is true, then the singularity may never have existed physically at all. It may simply mark the point where our current theories stop being reliable. And if the singularity disappears, something remarkable becomes possible. Time itself may continue beyond what we once believed was the beginning. At first, that idea feels almost impossible to accept. Your intuition insists that every story must have a first chapter. Every journey needs a starting point. Every effect must follow a cause. Yet physics has repeatedly shown that intuition is not always a trustworthy guide. The universe has never promised to behave in ways that feel comfortable to the human mind. Some of the most ambitious theories in cosmology now explore exactly this possibility. They do not reject the Big Bang. Instead, they reinterpret it. Rather than being the birth of everything, the Big Bang may have been a transition, a dramatic transformation from one cosmic state into another. If that sounds unfamiliar, it is because popular science often simplifies an incredibly complicated subject. The evidence strongly supports that the universe expanded from an extremely hot and dense phase, but expansion is not necessarily creation. A balloon expanding tells you something important about its history. It does not automatically reveal where the balloon came from. And once you separate those two ideas, the mystery becomes far deeper than the Big Bang itself. Because if there was something before, then the origin of the universe may lie hidden behind an event that was never actually the beginning at all. Several competing theories attempt to describe what might exist beyond that boundary. Some propose that our universe emerged from an earlier collapsing cosmos. Others suggest that quantum fluctuations transformed a timeless state into the expanding universe we observe today. A few even argue that the concept of before loses all physical meaning under extreme conditions. None of these ideas has been confirmed, yet all of them share one astonishing implication. The Big Bang may represent not the first moment of existence, but the first moment that our current understanding can meaningfully describe. And if that is true, then the greatest mystery is no longer what happened during the Big Bang, but what reality was doing before our story ever began. Among the oldest ideas in cosmology is one that feels almost poetic. Imagine the universe not as a single, unique event, but as something that breathes. Expansion would be nothing more than an exhale. Contraction and inhale. And instead of beginning once, the cosmos would pass through endless cycles, each one giving rise to the next. This concept, known in different forms as the cyclic universe, has appeared repeatedly throughout the history of theoretical physics. The details vary from one model to another, but the central idea remains remarkably similar. Our expanding universe may be only one chapter in an infinitely longer cosmic rhythm. Picture two enormous galaxies drifting toward each other across billions of years. Their collision would seem unimaginably violent from our perspective. Now expand that idea until the galaxies become entire universes. Some cosmological models suggest that events resembling cosmic collisions could generate conditions almost indistinguishable from what we call the Big Bang. In these scenarios, the intense heat and density of the early universe are not signs of creation. They are the aftermath of transformation. Matter, energy, and space-time are reorganized into a new cosmic beginning without requiring reality itself to emerge from absolute nothingness. There is something strangely satisfying about this picture. It removes one of the oldest philosophical problems. If every beginning demands a cause, then perhaps the universe never possessed a first beginning at all. Instead, every cosmic age emerges naturally from one that came before. But nature rarely rewards elegant ideas without demanding evidence. Although cyclic cosmology solves certain conceptual problems, they introduce new challenges of their own. Every cycle must preserve or reset enormous amounts of energy, entropy, and structure. Whether that can actually happen remains one of the biggest open questions in theoretical physics. Another possibility is even more unsettling. Instead of imagining countless universes appearing one after another, imagine reality existing in a permanent quantum state where the distinction between existence and non-existence becomes blurred. At unimaginably small scales, the quantum world behaves in ways that defy ordinary intuition. Particles appear and disappear within the restless fluctuations of quantum fields. Empty space is not truly empty. It seethes with invisible activity, constantly producing fleeting events that vanish almost as quickly as they emerge. Some physicists have wondered whether the early universe itself could have originated from a similar process, not from absolute nothingness, but from a quantum vacuum unlike anything that exists today. The word nothing becomes dangerously misleading here. In everyday language, nothing means the complete absence of everything. In physics, however, a quantum vacuum is anything but empty. It possesses structure, mathematical properties, and measurable effects. Calling it nothing is rather like calling the ocean empty simply because no islands are visible from the shore. If our universe emerged from such a quantum state, then the Big Bang would represent the moment when an invisible quantum landscape underwent an extraordinary transition. Reality would not appear from nothing. It would emerge from something far stranger than ordinary existence. This raises another question that is even more profound. Where did that quantum state come from? Once again, the mystery refuses to disappear. Every explanation seems to reveal an even deeper layer beneath it. The Big Bang no longer occupies the bottom of the stack. The quantum vacuum replaces it. But then the vacuum itself demands an explanation. You begin to notice a pattern. Every attempt to identify the ultimate beginning seems to uncover another doorway. Every answer quietly transforms into another question. The deeper cosmology explores reality, the more the concept of an absolute starting point begins to dissolve. Some researchers have responded to this pattern by proposing something radical. Perhaps the universe does not require an external cause because time itself is not fundamental. This idea sounds almost impossible to imagine because your entire life unfolds as a sequence of moments. Yesterday becomes today. Today becomes tomorrow. Cause appears to precede effect. Yet several approaches to quantum gravity suggest that time may emerge only after the universe reaches larger scales. If time itself emerged gradually, then asking what happened before the Big Bang could become meaningless. Not because there was nothing before it, but because the concept of before had not yet acquired physical meaning. Imagine asking what lies north of the North Pole. The question feels perfectly reasonable until you recognize that north simply stops existing there. The problem is not the answer. The problem is the question itself. Some physicists suspect the Big Bang may occupy a similar role in cosmology. It could represent a boundary where familiar concepts like before, after, cause, and duration cease behaving the way your intuition expects. If they are right, then the universe has been challenging not only our theories, but the very language we use to describe existence. And that possibility may be even more astonishing than the Big Bang itself. Yet there is one final possibility, perhaps the most disturbing of them all. What if the search for a first beginning is impossible? Not because the answer is hidden, but because reality was never constructed in the way human minds naturally expect. Would that mean the universe has no first page? Or that we have been trying to read the wrong book all along?